Hello again and welcome back. This is Mr. Smith and this is 2.17, solving quadratic equations. This is our final lesson for the year. If this is the second semester of 2020, I don't know if I'll reuse these videos, but if I do, it might not be your final one. But for my class in semester 2 of 2020, congratulations, you've made it to the end. This is the final lesson and best of luck to you in your future studies. Let's just get into this. So 2.17 quadratic equations. Right up at the top, we just set the equation to equal 0. Whoops, that's not what I want. And basically what you're going to do is the equation where the highest exponent of x is equal to 2. We should know that by now. Solutions is the values of x that make the equation true for the roots. So in some cases that is just factoring the solutions for our standard form equal to 0. This is just the zeros of the standard form. So when we were factoring, it was just the zeros or the x-intercepts. In this case, we are likely going to use the quadratic formula. So you solve by finding the solutions, solve, eliminate all terms from one side of the equation, then you're going to factor, and then you're going to isolate your variables, and then you're going to use the quadratic formula. Now, if you don't remember the quadratic formula, you can always go back and check. It should just be x is equal to minus b plus minus square root b squared minus 4ac all over 2a. That should be your quadratic formula, and you'd sub in all of your values accordingly. Okay, now that we recall our quadratic formula, we can move on with solving by factoring. So in our first equation here, we can't take out a common factor. We're going to check to see if we actually can factor this. What multiplies to 48 but adds to 2? So multiplies to negative 48. That is key. But adds to 2. Well, I'll give you a second to answer that. If you said 6 and negative 8, you are correct. Or 8 and negative 6. Sorry, I got those mixed up. And then I reveal this. So then our zeros are x equals 6, x equals negative 8. Perfect. Those are your solutions. We're solving by factoring. All right. Same idea here. We're going to take out a common factor first, so it should look like this. Take out a common factor of your a value first, if you can. Then we're going to factor what's in the brackets here, what adds to negative 9, but multiplies to 18. Well, negative 6 and negative 3 do. So then we're here. That means that our x values are going to equal 3 and positive 6. Next example. Can we take out a fact? Well, actually, we have to isolate the variable. We have to bring the 10 over. The 10 will become negative, and we'll get 50. Can we take out a factor of 6? Well, no, because 35 is not divisible by 6. So we're actually going to have to use the Xbox method. So in this one, use the Xbox method. It is factorable, but you need to use your Xbox method to solve, or the modified man method that I taught as an alternative lesson. I don't recommend you can use the quadratic formula to solve, but it's not necessary. Okay. So here is the factored form using the Xbox method, and then your zeros are your 5 over 2. Because 5 over 2 in the first brackets gives you 0, and then 10 over 3 gives you 0 in the second set of brackets. Okay. Oops. Next slide in 3, 2, 1. Okay. Solve using the quadratic formula using exact answers only. And I'm just going to write at the bottom what the quadratic formula is, just to kind of help you guys remember. B squared minus 4ac all over 2a. Okay, so we'll understand what that is. A always goes with x squared, b is always with the single x, and c is with the last constant term. Okay, so the first example here, I'm going to move the negative 3x squared over to the left side and the 2 over to the left side. And those are going to become, well, the negative 3x squared is going to become positive. Then we'll have plus x. Then we'll have minus 2 is equal to 0. If you chose to move the x over to the right side, you could still do it and work the math out, and the answers will still be correct. However, this is just how I set it up. So then I'm going to sub in everything into the quadratic formula, because b is positive 1, so we get negative 1 here because it's negative b, plus minus square root of 1 squared minus 4, a value, which is 3, times c, which is negative 2, all over 2a, which is 2 times 3. Do our multiplications. You should get 25 under the square root sign, and then when you square root it, you get 5, so it's plus minus 5. So negative 1 plus minus 5. If it's minus 5, you get negative 1. If it's plus 5, you get negative 4. Or you get positive 4 over 6, which reduces to 2 over 3. So your x values are negative 1 and 2 over 3. All right. Same idea with the second example here. We're going to start isolating variables. We do need to convert it into standard form, so we expand first using FOIL for the left side, expand the negative 2 into both terms here, so we get negative 2x plus 6. When you expand this, it's just x times negative 3, x times x times negative 3 times x, and then negative 3 times negative 3. And this is what you get. It is a bit of a shortcut. If you need to review expanding, I suggest going back through the notes and some of the lessons on that. And now we collect like terms. So we start moving everything over to the left side. 4 goes over, becomes negative. 6 goes over, becomes negative. So we get negative 10 plus 9. That gives us negative 1. Negative 2 goes over, becomes positive 2x. So positive 2x minus 6x gives us negative 4x. And now we can actually sub this into our quadratic equation, like so. So you have 4, because it's negative b, plus minus square root of negative 4 squared, minus 4a, which is positive 1, times c, which is negative 1, all over 2a, which is 2 times 1. And then we solve. So you're at 4 plus minus root 20 over 2, which if you reduce down your radical there, you get 2 root 5. So you can actually divide these by 2, because you can take out a factor of 2 of the first term and second term. And then when you take out a factor of 2, the 4 becomes just 2, like it did here. And then the 2 root 5 just becomes root 5. So it's 2 plus minus root 5. And this is exact. Okay. Next example in 3, 2, 1. Solve by isolating the variable. So that means that we're going to move the 27 over. And then we're going to divide both sides by negative 3. And we'll have x squared is equal to 9. Well, you take the square root of both sides, and you'll get x is equal to plus minus 3. This is like method 1 of the last lesson, instead of factoring and solving. Same idea, what's going on here. We're going to move the negative 8 over, then we're going to divide by 2. Divide both sides by 2. That'll get rid of the 2 out in front of the brackets, and then that 8 will become 4. So now we're at this point. We can actually take the square root of both sides. So if I take the square root here, and of this, the squared and the square root sign will cancel out, and I'll have x minus 1.5 is equal to 2, plus minus 2. Which means that if I move that over, I'll have 1.5 plus minus 2 is my solution. And obviously 1.5 plus 2 is 3.5. Then 1.5 minus 2 is negative 0.5. And that's where those come from. I know I went through this a little bit quick. You can always rewatch the video. Or you can pause it and copy down these notes. It is pretty straightforward. It is following the method from last lesson. Okay, example 3. We have a rectangle that has dimensions of x plus 6 and 2x minus 5. Determine the value of x that has given the area of 55 centimeters. Well, to find area, it's length times width. So we're going to multiply these two by each other, and they're going to equal 55. Perfect. Now we need to solve for x. So what we're going to do is we're going to expand, which is FOIL, right? And that explains how we got that. X times 2x gives us 2x squared. And then we have x times negative 5. We get negative 5x. 6 times 2x gives us 12x. 6 times negative 5 gives us negative 30. We'll bring the 5 over, or the 55 over. So we'll end up with 0. And now we need to factor. Except we can't take out a factor of 2. So we're going to use the quadratic formula. You could try to use your Xbox method. If it doesn't work, you can always fall back on your quadratic formula. If you're just not seeing it or it's not going to make sense, because it would be what multiplies to negative 170 but adds to 7. So that is a little bit tricky to think of. So I would just go with the quadratic formula in this case and just sub in everything and solve. So you guys should know where these numbers are coming from. The b value, that's negative b plus minus square root of b squared minus 4ac all over 2a. And we reduce it down. We get negative 7 plus minus 27 over 4. We can't take out a factor of 4 of both, but we can solve, and we get 5 and negative 34 over 4. And the only length that really makes sense, because negative 34 over 4, I believe, will give us a negative length here, so that doesn't work. So x is going to have to equal 5. Yeah, sides are negative, so therefore x is equal to 5. So there was only one solution, one possible solution in a real-life application of this example. Okay. Final question of the semester. Congratulations for making it this far and listening to my voice for this long. Okay, let's move on. A ball is thrown upwards and its height in meters can be modeled using the equation h is equal to negative 4.9 t squared plus 7.5 t plus 1.75. T is the time in seconds. Determine when the ball lands on the ground and the maximum height of the ball. So there's two things we're trying to figure out, and we're given the standard formula. We can actually solve for t. So let's do that first. So using the quadratic formula, we jump to this point here. Everything was subbed in and then use the square root. It's going to be not a very nice number here. So we're given our two zeros. The only possible 0 would be positive 1.79 seconds or 74 seconds because it's positive. It's a positive root or a positive 0. And you can't have negative time. Okay, so now we have the two zeros. We can take them, add them together, divide by 2, and that's going to give us back the x value of the maximum height of the ball. So halfway between the two zeros is 0.765. You then take this x value here, or this t value here, sub it back into your original equation and solve. And you should get h is equal to 4.62. Therefore, the maximum height is 4.62 meters. This last lesson is a little bit of review of the quadratics lessons for the past 3, I believe. If you did have trouble with any of them, I would recommend going back and watching any of those 3. If you had trouble with factoring, I would go back and watch factoring. If you had trouble with the quadratic equations, though, I would go back to cycle 1 and look at the quadratic equation lesson as I go in a bit more in detail there. Like the second step of this example, I just jump right to the end because you guys have seen the quadratic equation so many times now. I would expect that you're pretty proficient with it. Okay, that should be enough to finish up the practice. I should have an assignment uploaded shortly if it's not up yet. And the absolute cutoff date for that would be June 22nd, but please get it in before then because I need to mark everything and have my marks in the morning of the 24th. So if I don't have time to mark it on the 23rd, I don't know what's going to happen, but we'll figure it out. All right, best of luck. If you have questions, post it on the forum.